Okay, for page 121, number 40, we have a 92 kilogram baseball player represented by this box, because I can't draw a baseball player. And he's sliding into second base, represented by that circle. The coefficient of kinetic friction is 0.61. And we want to know what is the magnitude of the frictional force. So for part A, we want to know what the frictional force is. Okay? So as always, we try to figure out what our, let's move this a little down, because we want to draw our free body diagram, try to keep track of our stuff. So if we're looking at our baseball player, that is 92 kilograms. Now he's sliding, so the only force he stopped pushing, there's no one pushing him. So the only thing we have in the x direction is the frictional force going this way. We have the force of gravity pointing down, and we have the normal force pushing up. Now the force of gravity is just his mass times his gravity, which is 92 times 9.81. So his force of gravity is 92 times 9.81. It's going to be 902.52 newtons. Pointing down, I don't have to put the negative because I already have the arrow. And these are all his forces. So, if I'm trying to find the force of friction, I know my force of friction is equal to the coefficient times the normal force. Now the coefficient's given to me, so we're good, but I don't know what my normal force is, so I want to figure that out. So to look at my normal force, I try to look at what's happening in the y direction. In the y, the net force is going to be 0 because this baseball player is not shooting off, he's not flying off into space, and he's not going to the center of the earth, he's just moving in the x direction. So his acceleration in the y is going to be 0. And the only forces acting in the y is the normal force pushing up and the force of gravity pushing down. So we're going to have 92 kilograms times his acceleration, which we don't know, is equal to the normal force. Oh, we do know his acceleration. Sorry, his acceleration is going to be 0 in the y direction. So equal to his normal force minus the force of gravity, which is 902.52 newtons. So I'm going to change this to a 0 because we know his acceleration is 0 again because he's not flying up into the air. He's not going to the center of the earth. So 0 equals the normal force minus 902.52 newtons. So that means his 902.52 newtons is his normal force. Now that I know his normal force, because that was the only thing we were missing, I can actually calculate his force of friction now. His force of friction is going to be the coefficient times the normal force, which makes me, they gave us the coefficient. The coefficient was 0.61. So we know this is going to be 0.61 times 902.52 newtons. So that's going to be 550.537 newtons, and it's going to be going to the left, but because the force of friction doesn't have a set direction, if we wanted to make it more official, we could have put a negative there, but the magnitude, meaning the absolute value without the direction, is 550.53 or 54 newtons. So that's part A. Now for part B, they tell us that if he comes to rest after 1.2 seconds, what was his initial speed? So we're trying to find out what his initial speed was. Now we know he came to rest, so his final speed was 0 meters per second, and we know that the total time was 1.2 seconds. So we want to find his v initial, so we know one more thing. So what we're actually going to do is we're going to try to figure out what his acceleration is. So to find his acceleration, we're going to look at the net force in the x direction. Because this baseball player is sliding, he is accelerating. We found that because the force of friction is the only thing acting in the x direction. We say that his mass times his acceleration in the x direction is simply going to be equal to the force of friction, because there's nothing stopping him. And his mass is 92 kilograms. We don't know what his acceleration in the x is, but we know that when we multiply it times its mass, we're going to get 550.50. I'm running out of space, so I'm going to put 0.54 newtons. So we divide both sides by 92 kilograms, so we find his acceleration in the x equal to and it's technically negative. So his acceleration in the x is going to be, according to how we drew it, negative 5.98 meters per second squared. So now we know his acceleration, we know his v final, and we know his time. So we should be able to solve for his v initial using our kinematic equations. Using our kinematic equations, we can use the first one, which says that v final equals v initial plus at. And v final is 0, v initial plus negative 5.98 times 1.2. So we get 0 equals v initial plus negative 7.18 meters per 7.18. So that means our v initial is 7.18 meters per second. And we're done. So for part A we found our force of friction, and for part B we found our initial velocity.